Hello and welcome to this solution video of year 2004 in year 2022 when I'm recording this. Recently one of my students said that the older exam papers of A level were harder and now they are easier. So I said, okay, let me bust this myth and show how easy they were. So let me solve the first question of that paper. Here they're saying sketch the graph of y equal to secant x between 0 and 2 pi. One longer and not so accurate method is to make a table. Yeah, in a table you write x, y, and from 0 to 2 pi. If you want to write pi, or you can write decimals because 2 pi is 6.28. 2 times 3.14. 3.14 is the value almost for pi, so 6.28, and just find the y values for as many as point as possible and draw the graph, but there is a chance that you may not get the shape well. Here in this video I'm going to tell you a smarter way of doing the same. What is that? We know that secant x, which they are asking, is reciprocal of cos x, and by now you may be very much familiar how a cos graph looks like. Let me draw that. So if this is 0 and if this is 2 pi, in middle we'll have pi, and cos is always between positive 1 and minus 1, right? So our graph will be, it starts from 1, reaches 0, minimum at pi, reaches at midline axis again, and reaches to 2 pi again. Since secant x, it is y. Can you see? Y equal to secant x. So if the y value we reciprocate for cos, we'll get the graph of secant. So let me draw it here. So this is the axis 0, 2 pi, pi, and let's halve this also, pi by 2 and 3 pi by 2. So this one here is 3 pi by 2 and this is pi by 2. Okay, and we'll reciprocate them one by one now. Let's take some points in between. Let's say this is 0.8. Let's say this is 0.3. Okay, and similarly I'll take some points here and reciprocate them. This is minus 1. Yeah. Alright, so let's see one by one. At 0, cos is 1. This is the graph of y equal to cos x, and we are trying to find y equal to secant x, right? So the reciprocal of 1 is 1. So let's say 1 is here. So our point will be reciprocal of 1 is 1. This is 0.8. What is the reciprocal of 0.8? If you put it in your calculator, you'll get 1.25. So somewhere here. So it's going up. 1 over 0.3 will be 3.33. Somewhere there. Now this 0. What is the reciprocal of 0? Reciprocal of 0 is undefined. That means at pi by 2 there will be an undefined line which is called asymptote, and the graph will go and never meet this. Okay, it will go like this. Now we have to go again. Let's say this is 0.3 again, but negative because it is in below 0, right? So negative 3.3. So let's say this is negative 1. So 3.3 will be somewhere below this, right? Okay. Now next, let's say this is 0.6. So reciprocal of 0.6 will be 1.6, somewhere there. And then minus 1. The reciprocal of minus 1 is minus 1. So we can see that this graph goes down again to the asymptote. And if I do the same thing here, I'll get an asymptote at 3 pi by 2 also, because the y value for cos at 3 pi by 2 is 0, and this graph will go down, and similarly it will be coming this way. This is the graph for secant x, y equal to secant x. Let me change the color so that it is cleanly visible to you. So we know that cos x graph is between 1 and minus 1. It can't be out of that, but secant x is actually out of that only. There is no value between 1 and minus 1. So this I do it little down, so it will go and touch minus 1. This is the graph of secant x, this one. Question number 2. Solve this absolute inequality. Both sides are having absolute signs. So let's do what? Let's square both sides. So 2x plus 1, when it is squared, there's no need for absolute, because after squaring, both of them become positive. So we'll expand this. 4x squared plus 4x plus 2 plus 1 rather, yeah, less than x squared. Okay, let's bring that x squared also to the left side. Minus x squared plus 4x plus 1, which will be 3x squared plus 4x plus 1 less than 0. Next step to solve this inequality, mind it, the original was absolute, not quadratic. So we must find roots before we can decide where are the solutions. Okay, to find roots, I will factor this. You can use your calculator straight away if it is capable. Otherwise, factor it like the way I'm doing it. Okay, we break the middle part 4x into two parts so that we can take something common here. So 3x plus 1 and x plus 1. So we get two roots here. This one will be 3x plus 1 equal to 0. For root, we make it equal to 0, okay? So x equal to negative 1 over 3. This gives us x plus 1 equal to 0, x equal to negative 1. Now, next step should be that we draw a number line and write the smaller number here. The smaller number is minus 1. Bigger number is minus 1/3. And now we will take some numbers here. In absolute, we have to be very careful. So we will take some number less than minus 1 and substitute in our inequality and see if it works. So less than minus 1, let's say minus 1.5 I'm doing. So I'm using this inequality now to verify if my answer is less than minus 1. So minus 1.5 is less than minus 1. So plus 1 less than negative 1.5 absolute. In place of these x's, I put negative 1.5. So it becomes negative 3 plus 1 less than negative 1.5 absolute. Negative 2. Negative 2 absolute is 2. And this will be 1.5. 2 is not less than 1.5. So no, this is not our answer. Let's say a number between minus 1 and minus 1/3. Let's say negative 0.5. Okay, 0.5 will be half, right? Half will be between these two. All right, negative half. So 2x plus 1. Let me do here. 2 negative 0.5 plus 1 less than negative 0.5. Okay, this becomes negative 1, yeah, plus 1 less than, if I remove absolute here, it is 0.5. 0 is less than 0.5, which is true. So yes, our answer is here. Let's see if our answer is greater than minus 1/3. Usually it is not, but we should always verify. Minus 1/3. Let me do it here. So a number more than minus 1/3 is 0. I will take 0. So 0 2 times 0 plus 1 less than absolute 0. So 1 is less than 0, which is untrue, right? So no, our answer is not there. So this is the section where our answer falls. So our final answer will be between minus 1 x and minus 1/3. X is between minus 1 and minus 1/3. This is the answer. Alrighty, number 3. Find the gradient of the curve with the equation this at the point this one. What can be more straightforward than this? We just have to differentiate this because gradient is nothing but dy over dx. Gradient of tangent is equivalent to gradient of the curve. It's the same thing. Okay, at a particular point, whatever is the gradient of the curve at that point, tangent's gradient represents that gradient. So that's why we will find dy over dx. Since there is a mixture of x and y, we will use implicit differentiation. And what do we do in implicit differentiation? We just differentiate them normally, but wherever we have a y involved, we add a suffix called dy over dx. That's it. That's what we do. So when I do, you will understand. Let's differentiate 2x squared. So differentiate with respect to x. So differentiation of 2x squared will be 4x. Minus 4 is a constant. X and y are multiplying. Whenever two variables multiply, we differentiate them by product rule. And we have to apply product rule here between x and y. So let's keep minus 4 out. And it will be the differentiation of x and nothing done to y. Plus differentiation of y, nothing done to x. And if we are differentiating y, I told you we have to suffix it with dy over dx. Okay? Plus, okay, here the differentiation of 3y squared will be just like x, 6y. 2 came and multiplied with 3 became 6, and the exponent went down by 1. Since we have differentiated y, we will add a suffix again, dy over dx. Differentiation of 3 is 0. Let's open the bracket first. So 4x remains 4x minus 4 times the differentiation of x, because I have written a prime here, is 1. So don't touch it. So 4 times just y plus, not plus, minus again, because it is multiplying with 4. Minus 4 and x is x. When we differentiate y, it is 1. So no need to write it. We just write dy over dx because we differentiated y. Plus 6y dy over dx equal to 0. Keep these two with dy over dx on the left side itself and take it common. So minus 4x plus 6y. They have dy over dx with them. We kept them on the left side, and this 4x and 4y will come to the right side. It becomes 4y minus 4x. And now if we divide this side by this, minus 4x plus 6y, and divide this also by minus 4x plus 6y, they cancel out. Dy over dx is this. Let me write it cleanly. 4y minus 4x, and in denominator I will have 6y first because it is positive. Minus 4x. This is dy over dx, but they're saying find the gradient of curve at 2, 1. That means x is equal to 2. So at x equal to 2, gradient, which is dy over dx, 4 times y is 1 minus 4 times x is 2, 6 times 1 minus 4 times 2. And please do not never cancel these two with negative in between. They are never cancelled. Some of you make this mistake. Don't do that. So 4 minus 8 is minus 4. 6 minus 8 is minus 2. They cancel. 4 over 2 is 2. This is the gradient of the curve. Question 4. Show that if 2 to the power x is replaced by y, then the equation of this one can be written as a quadratic equation in terms of y. Okay, so let's rearrange this equation first, and then we will substitute it equal to y. So 2 to the power x remains 2 to the power x, but 2 to the power minus x can be written as 2 to the power x to make it positive, the exponent, equal to 1. And now we will substitute 2 to the power x by y it becomes y minus 1 over y equal to 1. So whenever you have a denominator with one of the terms in an equation, you can multiply by that denominator so that it gets cancelled out and we are left with no denominator. That is what we want. So if I multiply y with y, it becomes y square. And minus 1 over y, when it multiplies with y, this y and y will get cancelled out. We'll be left with just minus 1. And then 1 multiplies with y gives us y. So let's put this y also to the left side. We are left with y square minus y minus 1 equal to 0, which is a quadratic equation in terms of y. Okay, let's see what is the second part. Hence, solve the equation. We have to solve this equation. So factoring will not be a good idea here, and please do not, because it's worth 4 marks, do not use your calculators to straight away give you answer and write 2 answers. No, use quadratic formula, which is minus b plus minus b square minus 4ac over 2a. This will give us our solution and the solution of this equation. So if I look at this equation, this is b minus 1. Yeah? The coefficient of y minus 1 is b. 1 in front of y square is a, and this one is c. So everything is 1 or minus 1. We'll just substitute that here. So minus 1 plus minus 1 square minus 4 times a c over 2 times 1. So let's complete it here. It will be 1 plus minus square root 1 plus 4 over 2. And we are left with 1 plus square root 5 over 2, or 1 minus square root 5 over 2. We know that square root 5 is 2.23. That is the value of square root, right? And that means 1 minus 2.23 will give us a negative number. This is negative, right? And we knew that this answer is for y. We have solved it for y. And y actually was 2 to the power x. 2 to the power x will be a negative number, right? In this case, negative, and which is not possible. 2 can never be a negative number, whatever is the value of x. Never. So this answer is inadmissible. We can't use this one. So let's focus on the other one. 1 plus square root 5 over 2. Y equal to 1 plus square root 5 over 2. This makes sense. So 2 to the power x. Yes, 2 to the power x. Y is 2 to the power x equal to 1 plus square root 5 over 2. Let's multiply this 2 with this 2. Since these both of them are 2's, we can write 2 to the power x plus 1 equal to 1 plus square root 5. As I told you, square root 5 is 2.23, three significant figures. So 2 to the power x plus 1 will be 1 plus 2.23. And let's continue it down there. So 2 to the power x plus 1 equal to 3.23. Now to evaluate x, we'll have to use log on both sides because it's an exponent. The variable is an exponent. To bring it down, we have to apply log. So it becomes x plus 1 log 2 equal to log 3.23, and x plus 1 will be in bracket multiplying with this. Divide both sides by log base, log 2, not base, and log 3. No, divide both sides by log 2, right? And log 2 here as well. Here it gets cancelled out, and we are left with x plus 1 equal to log 3.23 over log 2. Let's use our calculators to evaluate this particular part. 1.694. So x will be 1.694 minus 1, which will be 0.694. That is the final solution. Okay. Number 5. prove this identity. Sine square theta cos square theta is 1/8 of 1 minus cos 4 theta. So here if we look at the left hand side, okay, we have an identity which is in your formula sheet. It is sine 2a equal to 2 sine a cos a. Here we have sine square theta cos square theta, means sine theta cos theta squared. So let's manipulate this according to our situation. Let's square this as well as this, both parts we square. So new identity becomes sine square 2a equal to 4 sine square a cos square a. Sine square theta cos square theta resembles this without 4. So let's divide 4 here and divide 4 here. 4 and 4 gone. In other sense, this left hand side, now it can be written as sine square 2 theta over 4. This is left hand side if I follow this identity. Alright, my target is 1 over 8. So can I multiply this by 2 to get 8, and I multiply this also so that I get denominator 8. So my new step is 2 sine square 2 theta over 8. Right? Now, next target is to get cos 4a. And if I add plus 1 here and minus 1 here, that is not going to make any difference to the numerator because I'm eventually adding 0. 1 minus 1 is 0. And this is going to help me because there is one more identity, which is cos 2a equal to 1 minus 2 sine square a. This angle is double of this angle. Now look at this right hand side in this identity. Look, doesn't it match with this? 2 sine square 2 theta minus 1. Okay, so let me write minus 1 plus 1. Let's not write this plus 1 here so that it becomes easier to understand. 2 sine square 2 theta minus 1. It looks like this. Only difference is that 1 is positive here but 1 is negative here. 2 sine square a is negative here. 2 sine square 2 theta is positive here. That means we can change the identity. Negative cos 2a equal to 2 sine square a minus 1. I change the sign of all three of them and this becomes a new identity which is exactly matches with this. Only difference is here the angle is theta, here angle is 2 theta. Since cos 2a is double, this angle is double of this angle, I can write this as cos 4 theta plus, rather minus, it is minus, right? Because of this minus, it is minus, plus 1 over 8. This part became cos 4 theta because double of 2 theta. This angle is double of this angle. We have to always copy like this if we are using an identity. And now if we want, we can write this whole part as this 1 over 8 outside, 1 minus cos 4 theta here, and that is our right hand side. We proved it. Next part. Hence, find the exact value of this definite integral. And if you see, this definite integral is exactly same as the left hand side of the previous part. That means we can change it to the integration of this that we get as right hand side. So 1 over 8 is outside, I will keep it constant. 1 minus cos 4 theta d theta. This is the new definite integral, the new form of this one. Alright, so now 1 over 8 stays out and we'll integrate this one. 1, its integration is theta, minus integration of cos 4 theta will be sine 4 theta over 4, differentiation of the angle plus c, 0, 1 over 3 pi. Minus remains minus because the integration of cos is sine positive, right? Integration, differentiation of cos is negative sign, but this is integration, so we'll keep it negative. Alright, now we will substitute the values of the two limits given for this definite integral. So 1 over 8, let's keep it out. So I will substitute 1 over 3 pi first minus sine over 4 over 3 pi over 4 plus c minus 0 minus sine 4 times 0 is 0 over 4 plus c. This plus c and this plus c, they are subtracting, they will cancel out. No need to look at them. 0 is 0, sine 0 is also 0. 0 divided by 4 is also 0. That means this part, we don't even have to look at this. So what are we left with? 1 over 8, 1 over 3 pi minus sine 4 over 3 pi. It will be here, pi by 3. So in this quadrant, sine is negative. We'll get a negative, and pi by 3 is square root 3 over 2. And we have a denominator 4, so we'll divide this by 4, close and close. So final answer will be 1 over 8. We have 1 over 3 pi plus square root 3 over 8. This is the exact value. They said exact value. We got exact value. Alright, next one. Given that y equal to 1 x when x is 0, solve the differential equation. This one, obtain an expression for y in terms of x. Alright. So first let's try to initiate the solution of the differential equation. This information will help us to find the value of c when we reach there. So first rule of solving differential equations is that dy and dx should be numerators. Dy here is numerator, leave it here. Dx will go to the other side and become numerator, right? And then y should be with dy and x should be with dx. All of them are y's, there is no x. This plus 1 is also adding with y cube, so this will also move with this y cube. So there will be nothing with dx, but this y square will go and multiply here. So let me write y square here. And y cube plus 1 will go cross multiply to the denominator, so it will come here. Basically, y cube plus 1 and dx exchange the places through cross multiplication. And now we have to integrate both sides to get the solution. Alright, if you see, here is y cube plus 1. So let y cube plus 1 equal to say t. Okay, so what will be dt over dy? That means differentiate this with respect to y, which will be 3y square. So can I say that dt is 3y square dy, again cross multiply, right? And look here, we have y square, we have dy, we don't have 3. So let's put 3 in front and divide by 3, like this. So what is our new situation here? It will be 1 over 3y squared dy over y cube plus 1 equal to integration of dx. Okay. Now, since this is dt, we will substitute it by dt now. dt. And this we assume that t, y cube plus 1 is t, equal to dx. And we can integrate easily now. 1 over 3 ln t. If we have dt over t format, that's what it becomes. Ln t equal to dx. The integration of dx will be just x plus c. And before we proceed, we have to bring back y here. 1 over 3 ln y cube plus 1 equal to x plus c. So to evaluate c, we will use the condition they have given, y equal to 1 when x equal to 0. So 1 over 3 ln y is 1. So 1 cube plus 1 equal to x is 0 plus c. So that becomes 1 over 3 ln 2 equal to c. So our equation here becomes 1 over 3 ln y cube plus 1 equal to x plus 1 over 3 ln 2. Okay, they're saying expression, obtain an expression for y in terms of x, and this is not y in terms of x. That means we have to isolate this y. First, this 1/3 should go. So multiply this by 1/3, multiply this whole by 1/3. Okay, so 3 and 3 cancel out here. So what are we left with? Ln y cube plus 1 equal to, if we open the bracket, it becomes 3x, this 3 and 1/3 will again cancel out, so just ln 2. Yeah, okay. Now we have to remove this natural log from here. So y cube plus 1, we have removed it. The other part will become the exponent of e plus ln 2. Alright, now we have to get rid of the 1. So y cube equal to e to power 3x plus ln 2 minus 1. Okay, so let's complete it here. Y cube equal to, let's separate 3x and ln 2 so that we get rid of ln here. So e to power 3x times e to power ln 2. Yeah, when exponents add up, their bases can multiply, and that's what I'm doing here. So ln and e are inverse of each other, so they neutralize each other, so we're left with only 2 here. So y cube equal to 2 e to power 3x and minus 1. This 2 I wrote in front and made it the coefficient. Now this cube must go because we want an equation for y. So it will be cube root here and cube root there. Cube and cube root cancel out. Y is equal to, and cube root can be written as 2 e to the power 3x minus 1 to the power 1/3. And this is how we got an expression for y in terms of x. Question 7, part 1. The equation x cubed plus x plus 1 equal to 0 has one real root. Show by calculation that this root lies between -1 and 0. So whenever they ask us to verify or show that a root is between two numbers, just substitute, treat this as a function. So when x is equal to 0, take one of them and substitute. 0 cube plus 0 plus 1 equal to 1, which is positive 1. Now put the second number when x equal to -1, they are saying -1. So -1 square, -1 plus 1. They cancel out and we get a -1. So whenever the sign of the value of one side changes from positive to negative, that means in between somewhere we have a number which will give us 0, and this equation is equal to 0. That means your root lies between these two numbers, -1 and 0. So we will write the presence of root is indicated by the change of sign between x equal to 0 and x equal to, right, and equal to -1. And that's why that root lies between these two numbers. Let's go to second part. Show that if a sequence of values given by the iterative formula, the given one, it converges to the root of the equation given in part 1. That means, in other words, they're asking us to show that this iterative formula can be converted to the equation we had in part 1. That's it. And to convert that, xn plus 1 and xn both become x. And that's how we show that it was that equation which became this one. So in place of xn plus 1, I wrote just x. In place of xn, I will write just x. And this also, I will write just x. And I need to get, my target is x cube plus x plus 1 equal to 0 as far as I remember. Yes, that's the target. So let's cross multiply. 3x cube plus x, when I multiply this denominator there, equal to 2x cube minus 1. Let's take this to the left side. 3x cube minus 2x cube, then we have plus x here, and this minus 1 will become 1, and we'll be left with nothing on the right side, so that is 0. So that is 2x cube minus x cube is x cube, and then we have x, and then we have 1 equal to 0, which is exactly what they want. We showed that we get the same roots with this iterative formula as well. And next they might be asking, yes, they're asking to find the value of x by starting with x1 equal to minus 0.5, and this is the iterative formula we have, xn plus 1 equal to this. So let me write it here. Xn plus 1 equal to 2x cube minus 1 over 3x cube plus 1. It is square here and n here. So let's start with minus 0.5 as they have suggested. So x2, which will be the next after x1, because we are replacing this by minus 0.5, this becomes x1, so this will be x2 equal to 2 minus 0.5 cube minus 1 over 3 minus 0.5 square plus 1. Okay, so x2 comes out to be how much? Minus 0.125 times 2 is minus 0.25 minus 1 over positive 0.25, so 0.75 plus 1 minus 1.25 over 1.75, okay, minus 0.7143. Now this x2 will become our number and we'll get x3 because of it. So we'll use the same iterative formula again, minus 0.7143 cube minus 1 over 3 minus 0.7143 square plus 1, and in this case we get minus 0.6832. I'm rounding up to 4 decimal places. They have not indicated what should we do, but 4 places are enough to give us correct answer. Let's go to x4. It will be 2 minus 0.6832 cube minus 1 and 3 minus 0.6832 square plus 1. This gives us minus 0.6823, and we can stop here. Why do we stop here? Because they said two decimal places. That's what we have to show. If I round off this to 2 decimal places, I get minus 0.71. If I round this off, I get negative 0.68, and this also gives us negative 0.68. When two consecutive iterative numbers, they are equal, then stop. So your final answer is x equal to minus 0.68, correct to the nearest 2 decimal places. Let's see next one. Question number 8. Find the roots of this equation giving your answers in x plus iy format. So it is z square minus z plus 1 equal to 0. We will use quadratic formula as usual. So our a is 1 in this case because we have coefficient 1. B is minus 1, coefficient minus 1 again, and C is 1. Okay, one of the previous question was something like this, but with little differences. But yeah, this time we'll get a complex number for sure. So minus b, which is minus 1, plus minus square root b square minus 4ac, both are positive, over 2 times 1. So we'll get minus and minus become positive 1, plus minus, this will be a positive 1 again, 1, this will be positive 1, 1 minus 4, because minus 4 times 1 is minus 4, divided by 2. So 1 plus minus square root minus 3, 2, and minus 3 makes it a complex number. How to convert it to complex number? 1 plus minus square root 3 times square root minus 1 over 2. And that's how we get 1 plus minus square root 3i over 2. So they're saying find the roots and give them in this format. So let's write them in a proper format. It will be 1 over 2, separating the numerator, square root 3 over 2i, and 1 over 2 minus square root 3 over 2i. These are the two roots. The part 2, as far as I remember, they are asking obtain the modulus and argument of each root. Since they have just plus and minus, their modulus is going to be same. Let's confirm. For modulus, we square the real part, which is half, and we square the imaginary part, which will be 1/4 for this one, and then 3/4 here. 1/4 plus 3/4 is 1. Square root of 1, and because modulus cannot be negative, it will be just 1. For this root, in place of plus minus inside here, but this square will again make it 3/4, and so the 1 is the modulus of both. So modulus of both roots equal to 1. Let's talk about the argument. Argument, or let's focus on this one first. Argument is always tan inverse of the imaginary part divided by the real part. You can put this straight away in a calculator, but I'm doing it mentally. 2 and 2 cancel because they are the denominator of respective numerators and denominators. It becomes tan inverse square root 3, which is pi over 3. Similarly, the other one will be negative in place of positive square root 3 over 2. So the argument of second root will be tan inverse imaginary part divided by real part. 2 and 2 cancel again, and tan inverse minus square root 3. Obviously it will be in the fourth quadrant, and since the angle it goes like this from here, it will again be pi by 3 but in negative direction. So that argument is negative pi by 3. Okay, next part. Show that each root also satisfies the equation z cube equal to minus 1. Z cube equal to minus 1. So z cube equal to minus 1, this is what we have to prove, and our first root was half plus square root 3 over 2i. You can make it cube and expand it, so, or you can factor this. One of the factors will be the multiplication of these roots, but I'm not going this way. I'm doing the simpler straightforward method. Half plus square root 3 over 2i, say half plus square root 3 over 2i. Alright, let's open this one first. I will use this identity. A plus b square equal to a square plus b square plus 2ab. So square of half is 1/4. Square of square root 3 over 2 will be 3 over 4, the square of square root 3 over 2, and I squared, this I will also be squared, that will make it minus, and then plus 2ab, plus 2 times a times b, square root 3 over 2i, and then we have half plus square root 3 over 2i. So 1/4 minus 3/4 will be minus half. 2 and 2 cancel. We are left with plus square root 3 over 2i, and then we have half plus square root 3 over 2i. And now here I will use another identity, which is a minus b, a plus b equal to a square minus b square. This is a for us, this is b, a plus b, and a minus b, because there is negative here. Same terms but with negative on one side. So it will be a square. For me, a square is this. Square root 3 over 2 square will be minus 3 over 4, just like we did in this one. This was also square root 3 over 2 I. Alright, and then minus half square, minus half square. So which will be 1/4. Minus 3/4 minus 1/4, which is minus 1. And that's what they were trying to tell us. Show that the z cube is minus 1. I just did for one root, and they're saying both the roots. Let's see the question again. Show that each root also satisfies the equation, this one. So that means we have to do the same thing with the second root, but this time I'll be fast. So I will just fasten the video and you will understand. So we have shown for both the cases. Question number 9, they're asking us to express this function in partial fractions. Before we proceed, we should see that the degree of numerator is 2, whereas degree of denominator is 3 by multiplying these 3. So the conditions for partial fraction straight away are conducive. Let's get started. Otherwise, if they were equal or more, we would divide first and then carry out partial fraction. So I'm doing the partial fraction straight away now. Okay, let's assume this is equal to a over x minus 1 plus b over x minus 2 plus c over x plus 1. To find the values of a, b, and c, we'll first assume that let's find the LCM of these three, which will be exactly this. And to do that, our numerator will be equal to a multiplying with the other two, not with its own denominator. It is already there, so we need two more. So we will write x minus 2, x plus 1 here, plus b. X minus 2 is already there, so we'll write x minus 1, x plus 1. And then we have c. X plus 1 is already there, so we'll write x minus 1, x minus 2. To evaluate a, b, and c, we should first try to make one of the brackets equal to 0. Let's make this equal to 0. So let's x equal to 2 so that this becomes 0. So what does left side become? 2 square plus 7 times 2 minus 6 equal to 2 minus 2, this will be 0, so whole of this will be 0, so I'm not looking at it. 2 minus 2, this will also be 0, so I'm not looking at c, only b will be left. 2 minus 1, 2 plus 1. So it becomes 4 plus 14 minus 6 equal to 2 minus 1 is 1, 2 plus 1 is 3, 3b. So what does that give us? 3b equal to 18 minus 6, 12. 3b equal to 12, so b equal to 12 over 3, which is 4. Let's make another 0. This time we'll take x plus 1. We'll try to make it 0. So x equal to minus 1. We'll make it 0. So let x equal to minus 1. So left side becomes minus 1 square plus 7 times minus 1 minus 6 equal to, this becomes 0. This x plus 1 will also make this be 0. C will be the only one left. So minus 1, minus 1, minus 1, minus 2. Minus 1 square is 1, minus 7, minus 6 equal to minus 2, minus 3, 6c, positive 6c. Alright, so 13, minus 13 plus 1, minus 12. So minus 12 equal to 6c. C becomes minus 12 over 6, which is minus 2. So two of them we got. Now we can make one more assumption, and in that case, so 2 we have done. Okay, let's make it x equal to 1. That will make this 0. Okay, so let's do it here. X equal to 1. So it will become 1 square plus 7 times 1 minus 6 equal to, let's go back to our equation. What becomes 0? So this becomes, b becomes 0, c becomes 0, and a remains. So it will become 1 minus 2 and 1 plus 1. A, 1 minus 2, 1 plus 1. So 1 plus 7 minus 6 equal to minus 1 and 2, minus 2a. So it becomes 8 minus 6, 2 equal to minus 2a. A is 2 over minus 2, which is minus 1. We got it. So let's summarize what will be our partial fraction. Partial fraction will be a minus 1 over what was the first factor of the denominator, x minus 1, x minus 2, x plus 1. X minus 1, x minus 2, x plus 1. We got a equal to minus 1. What did b? B was, we got b how much? 4. B was 4, c was minus 2. This is the partial fraction. Let's see what is the second part. Show that when x is sufficiently small, x4 and higher powers to be neglected. This is the expansion of fx. Okay, so we have to expand it. So let's expand. For that we'll have to restructure this. It will be fx equal to minus 1, this one minus 1, multiplied by x to the x minus 1 to the power minus 1, because we are bringing it up. Similarly, 4 x minus 2 to the power minus 1, and then minus 2 x plus 1 to the power minus 1. And now we will expand this, all three of them individually, up to cubic. Okay, cubic power. And we need this formula for expanding them. If we compare 1 plus x with them, they are not exactly what we want, except for this. This is okay. 1 plus x and x plus 1 is same thing. So let's rearrange them to get it in the format we want. So minus 1, x minus 1. I will write that as minus x minus 1 plus x to the power minus 1. I rearranged the 2 inside here. Okay, then plus 4 minus 2 plus x to the power minus 1, and minus 2 1 plus x to the power minus 1. We 100% want a plus 1 here, not a minus 1. So what will I do? I will divide this by minus 1. I will have to divide this also by minus 1, and outside we will multiply by minus 1 to the power minus 1. Let's try to understand what I did here. whatever number I divide both of them with, which is minus 1 in this case, same number is multiplied outside also, but as a numerator with this exponent, though it is not going to make any difference here, but let's see. Similarly, we'll divide this by minus 2. I have to divide by the same number here, and I have to multiply by the same number with same exponent outside. This one is okay, so we don't have to touch it. So let's rearrange everything. Minus 1 to the power minus 1 will be minus 1 again. So minus 1 times minus 1 will be completely 1. It becomes 1, so there is no need to write anything now. Here, inside, it will be minus 1 over minus 1, which is 1. That's what we wanted. X over minus 1 will be minus x to the power minus 1. Here, minus 2 to the power minus 1 will be 4 divided by minus 2. Yeah, to make it positive, we make it a denominator. Here it will be 1, that's what we wanted, minus x over 2 to the power minus 1. And minus 2, 1 plus x to the power minus 1. Now all of them are 1 plus or minus something, and that's it. That is the need for applying this formula. Let's apply them one by one. So let's apply to this one first. So it becomes 1 plus n is minus 1 and x is not x. It was plus x, that's why it is x. In our case it is minus x, so we have to write minus x. Then we have plus n is again minus 1, n minus 1 minus 1 minus 1 over 2 factorial x square, and again we have to use not x square, minus x whole square. Then it is minus 1 minus 1 minus 1 times minus 1 minus 2 divided by 3 factorial to the power x cube, and you guessed it right this time, again minus x to the power cube. This is the expansion of just this. Let's expand the second one, which is 4 over minus 2. So minus 2. In this case, because it was 1 in front, we ignore, but minus 2 we cannot ignore. So we have to write minus 2 outside and expand this one. So same formula again, 1 plus n minus 1. In this case, x is not x, it is x over 2, minus x over 2 rather, this one. Then plus same minus 1. Now I'll write a shortcut. Minus 1 will be minus 2 over 2 factorial and minus x over 2 square plus minus 1 minus 2 minus 3 over 3 factorial and minus x over 2 cube. By now you might have understood what I'm doing, so let me do the third part, which is this one. So minus 2 again, 1 plus nx plus n minus 1 over 2 factorial x square plus n minus 1 n minus 2 over 3 factorial and x cube. Now we'll have to simplify all of them. So let's simplify this first one. This one first. So 1 plus x. Yeah, minus 1 times minus x will be plus x. This will be minus 2. This will be minus 1. So total it is 2. This thing is 2. And 2 factorial is also 2. So they cancel out. We're left with x square, that too positive, because this square will make negative positive. So plus x square. Now here, minus 3 times minus 2 is positive 6. Positive 6 times minus 1 is minus 6. And minus 6 divided by 3 factorial is also 6. Minus 1. So minus and minus x cube will make it positive x cube. Alright, minus 2, this one. 1 and they multiply plus x over 2. They again cancel out. Alright, this will be plus x square over 4, and here they again cancel out, but there will be minus 1 left, this minus 1, and this cube will make it minus x cube, so it will be positive again, x cube over 8. Done. Next, again this closes, minus 2, 1, minus x this time, they again cancel out, plus x square, and they cancel out again, minus is left and x cube. Now we have all in terms of a constant x square and x cube, just simplify them. So 1, I'm just collecting 1 with minus 2 times 1, then minus 2 times 1 again. Next, x minus 2 times x over 2 will be minus x, because 2 and 2 will cancel out. Here minus 2 times minus x will be positive 2x. Let's go to x square. Minus 2 times plus x square over 4 will be minus x square over 2. 2 and 4 will cancel out. Then we have x square here, which is minus 2x square. Okay. Then we have x cube. We have minus 2 times x cube over 8. That makes it x cube over 4. And then we have minus 2 times minus x cube, which is plus 2x cube. So 1 minus 2 minus 2 will be minus 3. X minus x cancel. 2x. X square minus x square over 2 will be x square over 2 positive. So minus 2 will be minus 3 over 2 x square. Now x cube. X cube plus 2x cube will be 3x cube, and 3x cube 12 minus 1 plus 11 by 4x cube, and this is what they might be asking for. Minus 3 plus 2x minus 3 over 2 plus x, 11 over 4x to the power 3. Exactly. Question number 10. The diagram shows the curve y equal to ln x over x squared. That is the equation of this curve, and its maximum point M. We can see that the curve cuts x-axis at A. Yes, write down the x coordinates of A. So x coordinate of A is the x-intercept of the curve. For x-intercept, we substitute y equal to 0, and we get our x-intercept. So y equal to ln x over x squared. This is the equation, right, of the curve. Will make y equal to 0. X squared goes and multiplied with 0 and few vanishes. So what are we left with? Ln x equal to 0. So to remove ln and find the value of x, it will make the other side e to the power 0, and which is 1. E to the power 0, anything power 0 is 1, so the x coordinate of this is 1, and they're asking just the x coordinate. Done. Find the exact coordinates of M. Now for M, which is a maximum, in other sense it is a stationary point, and to find the stationary point of any curve, we first find dy over dx, which is differentiation. We make it equal to 0 and we get stationary point. So let's differentiate y equal to ln x over x square, which will be, we'll be using quotient rule. So x square squared first, then we write x square here, and we differentiate the ln x. I hope you understand what I'm saying. If u over v is to be differentiated, it will be v square, which we have done just now. Then u prime v, we differentiate the numerator first and just write the denominator, which I have done there, minus u v prime. So I will differentiate the numerator, which is ln x. Differentiation of ln x is 1 over x minus u ln x multiplied by the differentiation of the denominator, which is 2x, is the differentiation of x square, right? And let me write the simplified form if possible. X and x square cancel out, so only one x left here. So it becomes, and let's take x common. First let's write normally and then we'll write 2x ln x over x to the power 4. This is dy over dx, which we have to make equal to 0. And then we have to find the exact coordinates. That means both x and y. Let's find x first. So this one, x minus 2x ln x over x to the power 4 equal to 0. This is what we have to find the value of x. So this x4 multiplies with 0 and goes like it did in the previous part. And in this, we are left with only numerator. They are the combination of algebra and logarithmic parts. So let's take x common so that it becomes easier. Isn't it? I've taken x common. So it becomes x 1 minus ln x square. Yeah, this 2 can become the exponent of x, logarithmic law. And now if it is equal to 0, we'll get two answers. One is x equal to 0. Second one is 1 minus ln x square equal to 0. So the first one is straightforward. This is one of the stationary points. Second one will be 1 equal to ln x square, and now to remove ln x square will be e to the power 1, and then to find x we will square both sides. So x becomes square root e, plus or minus, right? But we can clearly see in the graph that it is the positive side, so no need to write negative side. So we can see that the x coordinate of m, this x value, is square root e. So we got square root e as x coordinate. We have to find y coordinate because they're saying coordinates. That means y has to be found out, and we will substitute y x into this and we'll get y equal to ln x over x square. So y equal to ln x over x square. So y equal to ln square root e over square root e square. So ln and e, they are inverse of each other. So if you put that in your calculator, you'll get just half. Divide this square root and square cancel out. So half over e or 1 over 2e. When denominator and actual denominator they multiply, 1 over 2e is the y coordinates. So coordinates of m are square root e, which is x, and 1 over 2e, which is y. What's next? Use integration by parts to find the exact area of the shaded region. Okay, so there is no trouble here. We have the starting point, which is 1, we have the ending point, which is e, and we have simply find the area under the curve. No challenge here. And the equation of the curve is ln x over x square dx, and they're saying use by parts method. So L I A T E, we have a logarithmic, we have an algebraic part. All right, let's rewrite this. 1 to e x to the power minus 2 ln x dx, right? So u v prime logarithmic, this becomes u and this becomes v prime, and we know that integration of uv prime is uv minus u prime v. All right, so let's do that. Okay, so this is the question we have already here. U, we already know ln x, so that will be ln x. V, we have v prime x square, right? So let's write somewhere here. So v prime is 1 over x square, right? Which is x to the power minus 2. We got it here. So what will be the integration of v prime? V. And that's what we want, v here. This v. So will be the integration of x to the power minus 2. So it will be x to the power minus 2 plus 1 over minus 2 plus 1, which will be minus x to the power minus 1. Yeah. So minus x to the power minus 1 is v. Minus u prime. We have to differentiate u, which is ln x. What is differentiation of ln x? 1 over x. What is v? We just got it. Minus, let me write minus 1 over x. Yeah, because x to the power minus 1, if I want to make it positive, we'll bring it to denominator. So dx. Alright, so let's rearrange this one. I will write again minus, this minus, they're multiplying, okay? Minus ln x is numerator and x becomes denominator. Because of this minus, I'll bring it and make it denominator. Minus. Alright, what is here now? This minus and this minus make it plus, so let's make it plus integration of 1 over x square and dx. And 1 over x square, we just got it, because this is 1 over x square, isn't it? So our answer is minus ln x over x minus 1 over x plus c finally. I use this as minus 1 over x and then plus c. We want from 0 to, not 0, 1 to e. And let's substitute the values of e and 1. So it comes minus ln e over e minus 1 over e plus c minus ln 1 over 1 minus 1 over 1 plus c. First thing we should do, cancel c. Alright, minus ln e. Ln e is 1. Yeah, ln and e are inverse. So minus 1 over e minus 1 over e minus and minus. Ln 1 is 0. This is gone. So this will be plus 1. That's it. So minus e will be minus 2 over e plus 1. This is the area under curve. Are they asking exact area or anyhow? Let's see. Exact area. So that is the right answer. Minus 2 over e plus 1.